going to do right now is work on, on Tuesday you're going to have some data that you're going to have to take, and we're going to have to figure out what to do with that data. And so that's what this is. This podcast is for. So let's start off with you. This is you. That's your catapult. Here's the apparatus I showed you today. It's the force plate with a motion detector attached. The force plate is going to take the force, and the motion detector is going to take the velocity. So when you end up with your catapult, and you're going to place a little, I don't know, maybe it's a little mud ball on there, and it's going to fly in the air. Hopefully we can get a reading from that velocity, that motion detector, and let's get a reading from that force plate. We're going to put together a data table, and you're going to need this for your launch on the 22nd. And in your data table, you're going to need a few things. So I'm going to put our launch number. We're going to need the mass of the projectile here. We need that mass. We're going to need, don't ask me why it does that. We're going to need the velocity of the projectile. And we'll also need the force of the impact. Okay, so this is going to be in newtons. This will be in meters per second. This will be in kilograms. So you might have 1, 2, 3, or 4, or 5 launches. It really doesn't matter. As many as you can get, you will take your best launch, and you will keep the before each launch, you'll weigh your projectile. You will take, you'll try to measure the velocity of the projectile with the motion detector, and you will try to determine the force of the impact with your force plate. You will have enough to answer some questions that will be asked upon us at the end of the webfolio, which is due December, it's due December 1st. The first one is the momentum. How are we going to be able to determine the momentum of the impact? Well, we know the equation. Little p is equal to mass, I'll write it out, times velocity. Okay, so we also know that P is going to be in units of kilograms times meters divided by seconds. So we've done that, and we know that the momentum is how that force is carried through as the projectile is in motion, is in the air. We also can figure out the acceleration of the impact and say, okay, and so whether or how the impact is accelerating into the force plate. And we know that acceleration is equal to force divided by mass. So A is equal to F divided by M, which is, of course, from the F equals MA equation. So we can figure out both of those. We can also figure out something called kinetic energy. Kinetic energy is the energy of a moving object. The word kinetic means moving. So the energy of any object that is moving, whether it's water flowing over a dam, whether it is a baseball being pitched, has energy. We want to talk about how much energy it has. And so that equation, and we're going to have an exponent here, but kinetic energy is equal to 1/2 the mass times the volume of, or I'm sorry, not the volume, the velocity, but we're going to square that velocity. And the unit is going to be a kilogram times a meter, but that's going to be squared, divided by a second squared. So it's very similar to a Newton, but we have more exponents. That is also known as a joule, because the guy's name was Joule. So we still have mass, we still have velocity, we've got to square it, our units get squared, we have that. It's a little bit more complicated, but I think you can handle it. And that's going to be one of the other, we'll be studying energy after we get out of here, but I wanted you to we get out of this, this project, but I do want you to know what the kinetic energy equation is. We'll do that also for the machine project. So, tonight's homework, which is in addition to having packet 3.3 completed. A student launches a 0.2 kilogram Zuzupet with her catapult. She gets a reading of 1.4 meters per second for her velocity, and the force of her impact is 16.2 newtons. So you have three things to determine: the moment of impact, the momentum of the impact, the acceleration of her projectile in the force plate, and the kinetic energy of her projectile. Please do that on a separate sheet of paper to show me tomorrow. I'm going to let you keep it, but I want to see it tomorrow.